Hello everyone and welcome to my channel. In this tutorial we will talk about how to quickly design, model and analysis a structure. Okay, so before that please subscribe my channel and press the bell icon that you will get notifications while I'm uploading a new video. Okay, so I will start the modeling and analysis and designing process and ETABS software version 19. Okay, so let's start. I will just press a new model. Okay, and model analyzation panel, we have three options. One option is to use saved model, okay, and another one is use setting from a model file that you have created previously, and the third one is use built-in setting with this one. Okay, so here I will use metric standard, okay, or metric MKS. Okay, so and still section database will be American Society of Civil Engineering latest version. Okay, and the still design code will be this one, which is the new one, and concrete design code will be American Concrete Institute 318 2019. Okay, this one. If you want to know the information about that systems, you just press on this information box. You will see a dialog box that what units you will be using throughout the designing and modeling and analyzation process. Okay, so after that I will just press OK. Look here, new model template. Okay, in the model template templates panels I will use 7 okay, and X directions, grid lines, number of grid lines, okay, and 7 by Y directions, okay, and spacing of grid and X directions will be 4 meter, and spacing of grid lines, okay, in Y directions will be 5 meter, okay. Number of stories will be 6, and typical story height will be 3.3 meter, and bottom story height it will be 3.5 meter. Okay, so this time I will use flat slabs with perimeter beams. Okay, this one. Okay, so this panel will pop up. Okay, after that, okay, so I will use here the beams dimensions will be it will be 400 mm, and this one will be also 400 mm, and in Y directions it will be the same. Okay, so the dead load will be 1.44 kilonewton by meter square, and live load will be 1.53 okay kilonewton by meter square as per the American standard. Okay, so the slab thickness will be 170 mm, okay, in column size, okay, as a square it will be 500 mm, okay, 500 by 500 mm. Okay, so after that I will use restraints to be fixed, and the floor diaphragm, okay, will be rigid. Okay, this one. Okay, in drop panel in square, okay, so it will be 3 meter. Drop panel sizes in square, and its thickness will be so like 300. Okay, so after that I will do not change other things, it is okay. After that, okay, press OK and OK. Look here, the plan view and 3D view of the model has been created. Okay, and this one is the model explorer window. Okay, so if you do not need, you can just close it. Okay, if you want to bring it back, you just go to the options and you will get it back, the explorer window. Okay, so look here, we have columns, beams and slabs, and including the drop panel. Okay, in case of that columns. Okay, now I will just click the specification for slabs. Okay, I will go to the section properties, slab sections, and I will just modify this one and slabs. Okay, and material will be 4000 psi and the modeling type will be shell thin. Okay, so and thickness is 170 mm. After that, okay, and okay. Now I will select this one, rectangular. Okay, and I will select the property type will be openings, and I will create openings for shear walls. Okay, so I want to create here 1 2 3 1 2 3. Okay, here in this portion. Okay, first of all, okay, I will select here all stories. Okay, and now I will create opening here. Here, look here, it has been applied for whole structure. Okay, so now I will select this column. So now I will select all these columns and I will delete this one because here in this portions the shear walls will exist. Okay, so I will just click on this column and I will press the control and will click. This window or selection list will come. Okay, after that I will press this one. Okay, and look here, this one. Okay, so and after that I will press OK. The columns for whole structure has been selected. Okay, and same as for this one, I will just press Control and will left click here and will select column. Okay, all columns has been selected. Same as for this one, Control plus left click. Okay, and columns. Okay, the same as for this one, press Control and left click. Okay, and select this one, Control left click column. Okay, Control left click and column. Okay, all these columns has been selected. After that I will just delete these columns. Okay, so these columns did not select. I will just press Control and left click. Okay, and after that the same Control and left click columns and delete. Okay, all columns in this portion has been deleted for whole structure. Okay, now I will use wall stack features. Okay, for rapid creations of shear walls. Okay, I will go here to the draw and draw wall stacks. Okay, new stacks, so I will use this shape. Okay, and length and x directions will be okay, and x directions will be 4 meter. Okay, so and ly one will be 5 meter and this one will be also 5 meter. Okay, so and the thickness will be 300 mm for each and every pier section, and also 300 mm and 300 mm. Okay, so after that, okay, so let it will be 4 4 meters and this one will be 5 meters. Okay, so yeah, and I will change the angle to 90 degrees. Okay, and press enter. Okay, look here, and I will press this. I will remove this one. Okay, and we'll press here. Okay, the shear walls for whole structure has been drawn. Okay, look here. So now I will go to for load patterns here, and I will define load. Okay, like earthquake x directions, and the type will be seismic, and the code will be American Society of Civil Engineering 716. Okay, and after that admin load, and same as for okay for x negative direction. Okay, the same code and the same seismic type. Okay, so this is x positive. Okay, modify. So the same as for y. Okay, and the type will be seismic, and the code will be the same, the latest version, and after that press the admin load, and the same as for y negative and admin load case. Okay, and also for vent in x direction, I will give this type as a vent, and this American standard admin load case, the same as for y direction. Okay, and the same code. Okay, so now I will just click for earthquake in x directions positive. I will modify this one. I will uncheck others. Okay, and I will just select x directions plus eccentricity, and I will use SS will be 1.15, and for S1 will be 0.51. Okay, so and the site class will be B, and also I will use the time period to be program calculated, and the response modification factor will be like it will be 6.5, and ever strength factor will be 3, and deflection amplification will be this one the same, and occupancy importance factor will be 1. Okay, after that, okay. And now I will modify this one. Let's click for x negative direction as well. I will click modify lateral load. I will uncheck others. Okay, and I will just click and tick mark x directions minus eccentricity. Okay, so and this one will be 1.15, and the S1 will be 0.51. Okay, the site class will be B, and the response modification factor will be like 6.5, and aversion factor will be 3, and deflection amplification factor will be 5.5, and occupancy importance factor I will be 1. Okay, so the time period will be program calculated, and the story range will be from base up to 6th story. Okay, after that press OK. The same as for Y, modify lateral load, and I will unclick others, and I will just leave the Y direction plus eccentricity. Okay, and I will change this one to 1.15 and this one to 0.51, and the long period will be 8. Okay, the site class will be B, and the response modification factor will be 6.5. Okay, and the aversion factor will be 3. This one will be the same, okay, as for x direction. Now I will modify this one for earthquake y negative direction as well. Okay, I will tick mark only the y directions minus eccentricity. Okay, and I will change these values as I have changed previously for x direction as well. Okay, and it will be program calculated. Okay, and press OK. The same as I will change here for y for x directions in wind, modify lateral load for wind. Okay, I will use exposure from extents of diaphragm. Okay, I will put here 100. Okay, and the extension type will be B. Okay, and I will use exposure height from story 1, okay, up to story 6, and I will use wind pressure coefficient by program determined. Okay, after that I will press OK. The same as for y directions, I will modify this one. I will put here the wind speed as 100, and the exposure type will be B, and the bottom story will be story 1. Okay, and wind pressure coefficients will be program determined. Okay, after that, okay, I have defined load patterns, and I have modified for earthquake x directions, earthquake y directions, and wind in x and y directions respectively. After that I will press OK. I will define the mass source. Okay, I will add new mass source. Okay, I will put a name here, mass source. Okay, I will click this on specified load patterns, and I will press here dead load. Okay, and multiplier is 1, and live load and 0.25 as a multiplier. Okay, after that add and okay, and this one I will, okay, for this one I will use this mass source. Okay, mass source. Okay, and okay, I will delete another extra one. Okay, so mass source, I will delete this one as it is extra. Now I will go to define, and I will go for load combinations. Okay, add default design combo, and I will use concrete frame design. Okay, and press OK, and after that I will just okay. Now before another step, I will just save this model. Okay, Ctrl+S, and I will specify the locations where I want to save this model. Okay, desktop, and this folder I will give a name. Okay, quick design. Okay, and I will just press save. Okay, now I will define the time history function or nonlinear dynamic analysis. Okay, so for that use I will just find one earthquake record. So I will, considering that earthquake record, I will use for time history functions. Okay, we'll go for define functions time history, and after that file, add new function. Okay, and browse the locations. Okay, where I have saved this time history functions for earthquake record. Okay, I will use this one, Kujali Maslak X direction. Okay, press open. Okay, I will use here Maslak in X directions, and headline lines to skip. Okay, will be 4. Okay, I will just give the file. Look here, 1, 2, 3, 4. 4 lines will be skipped. Okay, and number of points per lines will be 5. Okay, look here, 1, 2, 3, 4, and 1 is here, which is not completely visible. 5. Okay, and the time interval will be like this one. Okay, I will copy this one and will paste here. Okay, after that, okay, earthquake in X direction has been defined. Now I will go again for earthquake in Y direction. Okay, this time I will use Kujali Maslak in Y direction. Okay, so these earthquake records you can watch my other tutorial for getting the earthquake records, okay, from peer ground motion database, okay, which link is in the description box. Okay, so header lines to be skipped will be 4 and points per line will be 5. Okay, so and also the time interval is this one. After that, okay, this is for Y direction, and okay, we successfully defined the earthquake records in X and Y directions respectively. Okay, you can also define in the same way. If you don't know how to get earthquake records, okay, from peer ground motion database, okay, please watch another tutorial, okay, which link is in the description box. Okay, after that I will press OK. Now I will select object type and will go here for floors, select. Okay, all floors has been selected. Okay, now I will go for define or assign here, shell and diaphragm. Here, this one, diaphragms. After that, D1 apply. Okay, the diaphragms for all structure has been defined. Okay, so just look to the 3D view. Okay, so after that, okay, now everything is ready. I have defined and assigned everything. Okay, so now I will just press run analysis. Preparing. Okay, properties for analysis. Okay, please wait, the analyzing process has been started. Okay, so it will take a little bit time and we will see its result shortly. Okay, yes, analysis has been completed. Okay, so now I will look here to the deform shape. Okay, in 3D. So if you want to look, it is another properties, like for example for cases, dead load case. Okay, I want to, like here for dead load case, I want to see the shear forces. Okay, so you will have a shear forces and also for shear 3-3. Okay, and also bending moment in 3-3. Okay, you just look here, it is a bending moment. Okay, so for other combo you just also click and the bending moment. Okay, for other combination as well. Okay, so also now I will go here for design check. For concrete design check, I will just go here, start design check. Okay, the concrete designing process has been started. Okay, it is designing structural element, concrete structural element one by one, and it is checking whether it is adequate or not. Okay, the concrete designing process has been completed. Now we will see it is longitudinal reinforcement for columns and beams. Okay, so like look here, I will just select these columns and I will press right click. Okay, and look for detail. Okay, and after the details, look here, the design details for column. Okay, for first story. Okay, all the information has been given here. Okay, so if you want to export or download it, you will just press this on export to Word document. Okay, to be used for future purpose or uses. Okay, look here, all the information about the design force, momentum 2-2, M33. Okay, and the rebar percentage. Okay, and also the shear design forces, all information has been there. Okay, for other column you can just check as well. Okay, if you want here to see the display information. Okay, look here for percentage, come here, and rebar percentage. Okay, look here, this is rebar percentage for beams and columns. Okay, so 1% reinforcement should be provided for columns. Okay, now I want to see whether all members has been passed or not. I will go here and I will select here verify all member passed. Look here, ETABS showing that all concrete frame passed the design check. Okay, so now I will go for shear wall designing. I will go here and shear wall design sections, and I will do the same designing check as I have done for concrete frames for beams and columns. Okay, I will just press here start design check for shear walls. look here, the design check for shear walls has been completed. Okay, now I will go for display design info. Okay, so I can just check for DC, demand over capacity ratio for shear walls. Okay, look here, I will go here, select object type and walls, select. Okay, and here I will show select the object only. Okay, the shear walls has been selected. Okay, so look here, I will click here. Okay, or I will click here and I will just go for details. Okay, look here, it is ETABS shear wall design. Okay, all the informations about pier sections of the shear wall has been here. Look here for flexural design forces and moment. Okay, so this is the combination of the demand forces. Okay, and this is also the shear forces design after analysation. Okay, and you can get all the information about pier sections. After that, if you want to use it for future purpose, you will just go and export to the Word document. Okay, so go to assign shell pier level. Okay, and I will select these pier section. Okay, and I will apply P1 pier name. Okay, pier level. Okay, after that I will apply. Okay, and okay, now look here, it is showing P1 pier level for these pier sections, but others are P2. Assign shell level, and I will modify, and I will give a name here for P3 pier level, and I will add new name. Okay, this is P1 pier and this is P2. This one will be P3. I will select. Okay, first I will I will select this one. Okay, and I will assign the pier level as a P3 for this pier section. Okay, so this is P1 pier section. Look here, this is P2, this is P3. Okay, and this one will be P4. Okay, I will first define that one, add new. Okay, look here, I will select this pier section. Okay, and I will assign P4. Okay, look here, P1, P2, P3, and this one will be P4. After that, press OK. Now it will be easy to see for design for detailing information of each pier sections, because now we have 4 pier sections with different name. For each pier sections, if you want to go it is detailing, it will be easily to get the information for each and every pier shear wall sections. Okay, now I am going to take the information about shear forces for columns and shear walls. Okay, now I will select one column, like here I will go to elevation view. Okay, and I will select this column. Okay, and I will go to display and show tables. Okay, after that I will come here to the design sections, and I will come here for design forces about columns. Okay, we'll click this one, and after that okay. Look here, I want the shear forces V2 and V3. Okay, I have this one both. Okay, for different load combinations. Okay, like I want this one for these load combinations. Okay, or for each and every load combinations, if you want, you can just get one. Okay, so I want for this this load combination, and I want for all stories. If you want for one story, you can just select that one. Okay, I want for all these rows I will apply multiple item filter. Okay, so and columns is the C5. Okay, and all these informations about shear forces, V2, V3 and torsional forces, moment and other information is given. If you want to use it for another purpose, you just export it to the Excel sheet by clicking the file and export to Excel sheet. Okay, it will be exported to Excel. Okay, so this was the way how to get the shear forces and torsional forces information after analysis. Okay, now like you have learned how to get the shear forces informations, okay, about columns. Okay, the same as you can get for shear wall as well. Okay, so all the information has been there. Okay, you can just look for it. Okay, and thank you very much for watching this tutorial. If you have any doubt and questions, please write it down in the comment section. Okay, I will try to answer as soon as possible. The bell icons for getting the notifications while I uploading a new video. Thank you so much. Have a great time.